Hello, ladies and gents. Welcome to part 12 of Learning Rust. This is Connor. So we are going to be learning about methods. Methods are similar to functions. We declare them with the fn keyword and a name. They can have parameters and a return value, and they contain some code that's run when the method is called from somewhere else. So they are functions. Unlike functions, though, methods are defined within the context of a struct or an enum, a trait object, which we cover in other chapters, and their first parameter is always self. Okay, so methods first parameter is always self. This is very similar to Python, which represents the instance of the struct the method is being called on. Defining methods. Let's change the area function that has a rectangle instance as a parameter and instead make an area method defined on the rectangle struct, as shown in listing 5-13. Okay, so we got that. Width and height, rectangle struct. Now we need an impl, implement rectangle. So rectangle implements this method. Function area, address of self is passed as a parameter here to the method. U32 is the return value type, unsigned 32-bit integer. And then you return self width times self height. All right. And then function main, we get a rectangle here without the debug things. I'm going to remove these and the scale. And then print line the area. Print line the area is this thing, pixels squared. And let's get, so this is how we do it. So semicolon there. And that is going to take rectangle1 area as the variable here. All right, let's cargo run this. The area is 1500 square pixels. Okay, so you do impl rectangle, and inside that you define the function, which then becomes a method that belongs to the rectangle struct. To define the function within the context of rectangle, we start an impl implementation block for rectangle. Everything within this implementation block will be associated with the rectangle type. Then we move the area function within the impl curly brackets and change the first, and in this case only, parameter to be self in the signature and everywhere within the body. Right. In main, where we call the area function pass rect1 as an argument, we can instead use method syntax to call the area method on our rectangle instance. So here rect1 and then method. We add a dot followed by the method name, parentheses, and any arguments. Right? So this is very similar to other C family programming languages that are object-oriented or that have that implement object-oriented things. In the signature for area, we use the address of self instead of rectangle, address of rectangle. The address of self is actually short for self, address of self. Okay. So let's read that again. We use address of self instead of rectangle, address of rectangle. Here in the implementation, we use address of self. This thing is actually short for self, address of self. So this is the self name inside the function definition is the parameter name, right down here. We're using this, referring to this. This, on the other hand, refers to the address of the object, the implementation of the struct, that is, the address of the implementation of that implementation of the struct. So in this case, rect1. So address of self refers to the address of rect1 when you use the method with it. Okay, this is interesting. With an implementation block, the type uppercase self is an alias for the type that the implementation block is for. Methods must have a parameter named self of type self for their first parameter. Right. So this here is an implementation, or refers to the instance of the rectangle object, or the rectangle struct, rather. Methods must have a parameter named self or of type self for their first parameter. So Rust lets you abbreviate this with only the name self in the first parameter spot. Note that we still need to use the address of in front of the self shorthand to indicate that this method borrows self instance, just as we did in rectangle address of rectangle. Methods can take ownership of self, borrow self immutably, as we've done here, or borrow self mutably, just as they can any other parameter. We chose address of self here for the same reason we use address of rectangle in the function version. We don't want to take ownership, right? We want to do something with the data, we don't want to take ownership of the data. We just want to read the data in the struct, not write to it. So if you're going to read the data in the struct, not write to it, you don't take ownership. If we wanted to change the instance that we've called the method on as part of what the method does, we'd use address of mute self as the first parameter. Having a method that takes ownership of the instance by using just self as the first parameter is rare. This technique is usually used when the method transforms self into something else and you want to prevent the caller from using the original instance after the transformation. Right. In the ownership model, Rust. Once you take ownership, once your function takes ownership of a Rust object or some data that's stored in memory, that function now owns it, and the object is no longer valid outside the function unless the function returns it back to wherever it's called. Okay, the main reason for using methods instead of functions, in addition to providing method syntax and not having to repeat the type of self in every method signature, is for organization. We've put all the things we can do with an instance of a type in one implementation block, rather than making future users of our code search for capabilities of Rectangle in various places in the library we provide. Yes, so code organization, which is one of the things that object-oriented programming concepts are useful for as well. Note that we can choose to give a method the same name as one of the struct's fields. For example, we can define a method on Rectangle that is also named width. Okay, function width, bool, self width larger than 0. If the width is larger than 0, there is a width. This is going to return true. The rectangle has a non-zero width. It is rect width. If rect width, if this function returns true, or the method, the width method, returns true, then it prints this to the console. Okay, sure. Here we're choosing to make the with method return true if the value in the instances with field is greater than 0, and false if the value is 0 or negative. We can use a field within a method of the same name for any purpose. In main, when we follow rect with parentheses, Rust knows we mean the method with. When we don't use parentheses, Rust knows we mean the field with. So this call here refers to this field, and this call is to the function, this function right there, or the method. They're called methods now because it's inside an implementation block. Often, but not always, when we give a method the same name as a field, we want it to only return the value in the field and do nothing else. Methods like this are called getters, and Rust does not implement them automatically for struct fields as some other languages do. Getters are useful because you can make the field private but the method public, and thus enable read-only access to that field as part of the type's public API. We will discuss what public and private are and how to designate the field or method as public or private in Chapter 7. Where is the arrow operator? In C and C++, two different operators are used for calling methods. You use dot if you're calling your method on the object directly, and an arrow if you're calling the method on a pointer to the object, and need to dereference the pointer first. In other words, if object is a pointer, object something is similar to getting the object dot something. Right? Rust doesn't have an equivalent to the arrow operator. Instead, Rust has a feature called automatic referencing and dereferencing. Calling methods is one of the few places in Rust that has this behavior. Here's how it works. When you call a method with object something, Rust automatically adds address of mute, or I think this is pointer. I'm not sure. I'm not very well versed in this notation, basically. So object matches the signature of the method. In other words, the following are the same. p1.distance, address of p2, address of p1.distance, address of p2, right? The first one looks much cleaner. This automatic referencing behavior works because methods have a clear receiver, the type of self. Given the receiver and name of a method, Rust can figure out definitively whether the method is reading address of self, mutating at address of mute self, or consuming self. Okay, so this is consuming the object itself, passing the object itself to the method. This is passing the address of the object to the method. And this is for read-only access. If you do address of mute p1 here, you are passing, you're making the object writable. Yes, address of mute. The fact that Rust makes borrowing implicit for method receivers is a big part of making ownership ergonomic in practice. Methods with more parameters. Let's practice using methods by implementing a second method on the rectangle struct. This time we want an instance of rectangle to take another instance of rectangle and return true if the second rectangle can fit completely within self, the first rectangle. Otherwise, it should return false. That is, once we've defined the canHold method, we want to be able to write the program shown in listing 5-14. Let's write that. Do we have canHold anywhere? No. down here. Okay. The expected output will look like the following because both dimensions of rect2 are smaller than the dimensions of rect1, but rect3 is wider than rect1. Okay, so rect2 can fit inside rect1, but rect3 cannot fit inside rect1. Can rect1 hold rect2? True. Can rect1 hold rect3? False. That's the expected outcome. Let me just copy this into main. Let's remove that debug statement. We know we want to define a method, so it will be within the implement rectangle block. So in here, the method name will be canHold, and it will take an immutable borrow of another rectangle as a parameter. So something like this. It's already down here. canHold, first parameter is always address of self, which is the same as this. I'm just going to change this to that. And then the second parameter is going to be the other rectangle. This will return a Boolean, true or false. Now, if the width of our current rectangle is greater than or equal to the other's width, and then and self height is greater than or equal to other's height, actually you just return the result of this, right? That's it. Yeah. Okay, so this is a Boolean expression, and you don't need to type return or anything in Rust to return it. All right. And here rect2, rect3. What is this? Consider removing the borrow. This should be address of rectangle. That's the problem, right? Yep. Address of rectangle for read-only purposes. We know we want to define a method, so it will be within the implement rectangle block. The method name will be canHold. We'll take an immutable borrow of another rectangle as a parameter. We can tell what type of parameter will be, what type of the parameter will be by looking at the code that calls the method. Rect1 canHold address of rect2. Passes in address of rect2, which is an immutable borrow to rect2, an instance of rectangle. Right, so we define it here anyway. That's the instance of rectangle we're talking about. This makes sense because we only need to read rect2 rather than write to it, which would mean we'd need a mutable borrow. Yeah, if we wanted to write to rect2, we would need to do an address of mute rect2, right? Right here, we would have to say mute rect2, but we don't need that. We want main to retain ownership of rect2, so we can use it again after calling canHold method. The return value of canHold will be a Boolean, and the implementation will check whether the width and height of self are greater than the width and height of the other rectangle, respectively. Let's add the new canHold method to the implementation block from listing 5-13, shown in here. Right, yeah. Did that in the implementation block. What's happening here? Area is never used. Okay. When we run this code with the main function in listing 5-14, we get our desired output. If I go run, can rect1 hold rect2? True. Can rect1 hold rect3? False. I did greater than or equal to here. That's the only difference. I think this is more correct anyway. Okay. Associated functions. All functions defined within an implementation block are called associated functions because they're associated with the type named after the implementation. So these are associated functions. We can define associated functions that don't have self as their first parameter and thus are not methods because they don't need an instance of the type to work with. So these are associated functions of rectangle. They're also methods of rectangle because they implement address of self. But we can have functions that are associated with rectangle struct that don't implement this as a parameter, don't take self as their first parameter, and those are going to be just functions that are associated with rectangle. And they're not going to be called methods, which is very similar to other programming languages as well. String from is one associated function that we've been using, yes. Associated functions that aren't methods are often used for constructors that will return a new instance of a struct. These are often called new, but new isn't a special name and isn't built into the language. For example, we could choose to provide an associated function named square that would have one dimension parameter and use that as both width and height, thus making it easier to create a square rectangle rather than having to specify the same value twice. Let's do that. Function square. It just takes a size parameter, which is 32, integer. Guess we can't have real numbers as our width or height. Self. This is of course for demonstration purposes. It returns self. So a rectangle object with the width and height is equal to size. Height equal to size as well. And this is what it returns. Cool. It doesn't implement the struct instance, right? So self is not implemented here as the first parameter. So this is just an associated function, and these are associated functions as well as but they're methods. They're called methods because they implement self. Associated functions that aren't methods are often used, right? The self keywords in the return type and in the body of the function are aliases for the type that appears after the impl keyword, which in this case is rectangle, right? So these self refer to rectangle here. To call this associated function, we use the double colon syntax with the struct name, let square rectangle square 3 as an example. Okay, let's do that. Let square rectangle square size is 3. And of course, square is never used. This function is namespaced by the struct. The double colon syntax is used for both associated functions and namespace created by modules. We'll discuss modules later. Multiple implementation blocks. Each struct is allowed to have multiple implementation blocks. For example, listing 5-15 is equivalent to the code shown in listing 5-16, which has each method in its own implementation block. This is one method. This is another method. There's no reason to do this with this example, but it's valid. We'll see a case in which multiple implementation blocks are useful in chapter 10. All right, let's have a look at that later then. Summary. Structs let you create custom types that are meaningful for your domain. By using structs, you can keep associated pieces of data connected to each other and name each piece to make your code clear. In implementation blocks, you can define functions that are associated with your type, and methods are a kind of associated function that let you specify the behavior that instances of your structs have. But structs aren't the only way you can create custom types. Let's turn to Rust enum feature to add another tool to your toolbox. So this ends structs, I guess, and enums are going to be the topic of the next video. See you then.